What are we doing with Avocado OS?
Avocado is an attempt to be able to make embedded Linux more approachable for people who want to build products.
So what might feel like a nicety for getting the camera in the field quickly becomes a management nightmare, especially in Linux. You have a purpose-built OS for your device, to your point, which is completely reproducible and can be managed on a scale from not from 1 to 100, from 100 to 100,000.
We kind of take the best of both sides. We build our distribution on top of Yocto, which foundationally gives us the finite control to ensure that we're only building or extending the opportunity for you to build in what's necessary into the system. On the flip side of that, we also know that developers love to use of the convenience of the use of package repositories.
If anything we shared here today is of interest to you and you're looking to have a more reliable way to sell your edge products, Avocado is a fantastic answer there. And we will build the world so that you don't have to. Hey, everybody. Excited to dive in today a little bit more around the foundations of Avocado Linux, Peridio, and how and why we built the platform that we did and what we're doing today. Today, I have the pleasure of being joined with my co-founder and chief product officer, Justin Schneck.
Hey,
Thanks for
everyone.
being on the call. Yeah, good to see you, man. I think just take it from the top. What are we doing with Avocado OS? What is the thing?
Avocado is really it's an attempt to be able to make embedded Linux more approachable for people who want to build products. Those who might not be familiar with the term embedded Linux, you might be familiar with Linux in general, knowing it on desktops and servers for years. It's really what powers a lot of the web when it comes to these server installations. And on products that we want to create, smart TVs or computer vision applications, robotics, all of that. These are all things that are now a distributed computing problem. We have these, they need to get packaged up with a version of software, they need to run an OS and they have to run your applications in the way that you want to program them. And they have a bit of more challenges when it comes to how we manage that in the software stack. You kind of want to build these things so that they only have on them what they need to be able to run, so that their footprint of security is pretty tight, and that there are less vulnerabilities while they're out there, and less to go wrong, really. I mean, this landscape is pretty complicated when it comes to all of the different ways that a computer can look. Like I said, it can look like a TV, it can look like a camera, it can look like a robot. And with all these different ways that you can build this kind of stuff, these products, the challenge to getting something into market can be quite vast. And you and I, we've worked together for a long time, seeing this in practice and helping tons of companies be able to ship like hundreds of products into the field. And through that experience, we've just found that all these challenges just keep sharp edges just keep showing back up. Everybody's kind of starting over from zero again. It feels like with these long slog projects, and really, it was just about time to be able to rethink the way that we approach embedded Linux by not just trying to slam dunk what we've learned from the web directly down onto it.
Yeah.
But instead, kind of create a mechanism, a system, an OS, a distribution. All of these things are what make up Avocado, the spirit of Avocado. To make it easier to develop embedded products. Yeah.
I mean, a lot of these companies, vendors, you think there's dozens, if not hundreds of companies launching new gateways, new solutions that have cutting edge AI capabilities, and they're being shipped with desktop or server grade Linux. Why is that falling short?
Using a desktop variety is it's fine for debugging purposes. I mean, if you imagine a lot of these vendors that you're speaking of, they're trying to be able to make commoditized hardware that others can use to be able to easily reach for and create their product offering from as a starting point. The challenges of developing embedded products are high on the software side, let alone then the hardware side too. And if you have an idea that might enable some really useful functionality in industrial, consumer, wherever your product idea might take you, it would be helpful if you can reach for something off the shelf that you can just start to purchase and resell with your software solution on it. Those hardware manufacturers care about the customer experience to an extent that enables them to be able to get up and running and feel successful pretty quickly. And something like a Ubuntu or a desktop Linux-based operating system can give you that kind of feeling, but it's not necessarily what's great for the long term. When you have an operating system like this installed on your device, everything just kind of feels like you're managing servers. And when you have the comfortable approach to that in the data center, where there's always sort of a back door where you can kind of like, if you mess up something, you can have an escape hatch to get back in. When you distribute products into the field, you don't have that kind of luxury. And the best chance that you might have to be able to discover problems that are occurring is to be able to reproduce that back at home, like on your desk, on like another version of that product. You want to be able to put that device that's on your desk into the same exact state that the one that's distributed would be in.
Mhm.
And you can't really do that with these mutable systems that when you install these packages at runtime can kind of drift in state and uh, um, and kind of become their own sort of amorphous thing.
So what might feel like a nicety for getting the camera in the field quickly becomes a management nightmare, especially in Linux. I mean, yeah.
Yeah, and we said this stuff is hard. Like the software stacks are there's a lot of complicated things that are involved in this. And while being able to reach for that commoditized hardware off the shelf can solve a big portion of the problem for you, getting to a successful place for what would be a good proof of concept or a beta or MVP, whatever you want to call it, it's gonna be a, a bit of a task. And by the time you get to that state where you finally get it working, we always say as engineers, "Oh, we'll go back and fix it later," but a lot of those things they don't get fixed, and or they just get shipped how they are. And so it's what we often end up seeing is that people will start from this place, they'll end up building a lot of the world, and then they'll realize just how much effort and work went into creating this product that they're designing, and how much of a mountain of work it feels like to lift it up and put it onto something that's more reproducible, like Yocto or like a more image based system that's designed for building products.
Yeah, one thing that we hear a lot from our customers and partners is the gap between the conference demo and the real world experience. And I think that's a really nice window to look into how we're making life easier with Avocado. And so could you talk to me about maybe a hypothetical NVIDIA based computer vision solution that you see at the show and then you're trying to reproduce for your company?
Yeah, yeah. Uh, Joking aside, I guess I'll get the people counting out of the way. That's the one that you'll see at the show all the time. I've had enough of counting people. I think we can all do that one.
We got two.
Yeah. But these cameras have a really great home in industrial use cases on assembly lines and manufacturing facilities for being able to do quality assurance. You can imagine cases where you want to ensure that as parts go across the line or down a conveyor, that they all meet at least roughly some specification. There's interesting ones where if you have like a just a wide variety of widgets, and you want to, like, let's say screws for example, and you want to try to find the ones that aren't the same, you can quickly and easily do that by using computer vision based applications. But we've also seen it in personal protection or safety standards regulation, ensuring reporting is being done in an automated way, so that you can ensure that people are wearing hard hats, safety equipment, glasses, whatever might be required for a workplace environment. And these are just like seemingly easy things that you should be able to automate away. But up until the point where we've really had this advanced mechanisms to do computer vision processing, creating sensors to kind of do this where would be a really difficult thing to do. Right? There's nothing that would really be able to do it as well as being able to parse video feeds from a camera. Right? Seeing is believing in that case. So
Yeah, so like the you buy an edge gateway, maybe you buy a camera with the Jetson attached, and you it ships with the standard Nvidia tooling. And like, what's next? Like, what's that experience for getting the application live in the field? If minus avocado, like the compare and contrast.
Yeah, for sure. Yeah. So this will really help us understand where we're fitting in with stuff. It's the traditional way and approach is if you purchase some NVIDIA hardware or even from an NVIDIA vendor that's maybe producing some more comprehensive solution that could contain a camera or something like that. Usually, often NVIDIA would promote the use of this thing called Jetpack, which is just a fancy name for their version of the Linux kernel and some stuff from Ubuntu. It's basically like you treat it like an Ubuntu desktop. And notoriously, Jetpack, while, like we said earlier, makes it feel like you can get successful pretty quickly by installing packages at runtime and just mutating the system into a state that works. You hit these like challenges. For one, that's going to be how do you reproduce that? Like how do you provision 100 of them when you're ready to go?
Right.
But also how do you upgrade that? There's a bunch of problems when it comes to moving from versions of Jetpack to versions of Jetpack or migrating entire state. So really, you're kind of left with this like convolution of scripts and awkward provisioning procedures to be able to create many unique snowflakes. Or alternatively, you could use Yocto tooling. We've got friends over at a community called Open Embedded for Tegra, and they handle the interactions of creating and maintaining the Yocto layers. Yocto being a very popular build tool for producing immutable, deterministic, image-based runtimes that solves the problems
Hmm.
effectively of image-based updates. You can reliably put things into different states. You can OTA things more easily and more effectively. But that comes with its own complications. Imagine in that case, that's an opt-in system, as I would say, like versus Ubuntu, which is like opt-out in a way. Like, Ubuntu's going to come with all the bells and whistles turned on. It's going to be way like gigabytes in size because it's going to have all the options enabled and for you to be able to either have installed pre with the system or install yourself. And
It's a
with
full desktop grade OS. It's got everything you would ever
yeah,
need.
it's like trying to do the well. That's the side effect of plug and play, right? Like, isn't it
Yeah.
great that you can just buy this thing and plug it in and it just works? Well, that's because the software is already being shipped with the system. Versus Yocto, which is you have to kind of know what you want, and you get to pick and choose from this menu of recipes of what you want to build in, and what you're left with in the end is a system that you've built into it. Really, only what's necessary to drive your product and your application. And that comes with its challenges because you're kind of starting from a state where you have all the seatbelts turned on. And so it can feel really clunky from a development experience. If you boot into a runtime after you've finally imaged the system and you realize that you need some other package, then you have to go back to your desktop and enable that option and then rebuild and then reimage the system. It's this very monolithic approach, right? And
Yeah.
so on one side of the equation, you have something that's going to feel fast up front, but really tough to maintain over time and not very scalable for embedded products. And on the other side of that, with the Octo, you have something that is going to feel more in line with something that's going to be more scalable and maintainable for product development, but might feel slower upfront and feel like an inhibitor a bit, maybe even a friction to your development cycle. Right?
Yeah, we've been telling people for a while that we have production ready Jetson on a Yocto based architecture, and they think we're lying. They think we're kidding. And we know the four people that maintain that repo very well, very close, and NVIDIA employs one of them, and thank God for their work. It's standing on the shoulders of giants. But like what about Avocado is different than the traditional Yocto based approach?
Yeah, we kind of take the best of both sides, right? We build our distribution on top of Yocto, which foundationally gives us the finite control to ensure that we're only building or extending the opportunity for you to build in what's necessary into the system. On the flip side of that, we also know that developers love to use of the convenience of the use of package repositories. If you're feeling around in the dark or you're early in your development stages, your journey, being able to reach for packages and install them and just make it so that that stuff kind of works is really important. And you mentioned standing on the shoulders of giants. That's this entire industry. Like we're just,
Yes.
everybody needs to glue together all this stuff that all of us have collectively done to be able to get this job done. And so yeah, we are a binary distribution, in the sense that we do build packages, but it all comes together in the way that you compose our system. Like we have great developer tools that you can use on your desktop to be able to cross compile your applications with our SDK. You can extend the SDK with whatever support for languages you need, like Rust or Node or C or C++, all of these. And on Nvidia targets, we also support cross compilers for CUDA. So you can even do all of the accelerated stuff there as well. And then once you package all of that up into what we call extensions, which is a tried and true technology that was built by Systemd. Then at runtime, your entire system gets brought together, all your cross-compiled code, your applications, the packages you've chose, the system extensions that you've included will be able to just get written to disk in a very friendly way for provisioning. So, if you need to make 10,000 of these, like it'll be a really quick experience to reproduce 10,000 of them without sacrificing that quality of life for the developer as well. If you boot up at our system and you realize there's a package you didn't install, you can also reach for things like hardware in the loop to over the network mount in an extension, iterate on it by changing code in your application, compiling it again, and it immediately showing up on the device so that you can just test it right away, or add and remove packages as you might need. But so that way you're not doing it in a means that you're mutating the runtime, and once you've installed 60 packages, you're like, oh, which 60 were those again? You're kind of always at a position where you're ready to deploy and you're ready to be able to ship. So that's what really makes it production ready and high grade, with all that offering there, but without having the lack of scalability effect that you get from doing this all at runtime, right?
Yeah, one of the things that's really cool is that we've built these extensions in a way to where you can bring in like the whole Nvidia universe on day one, and to where your development teams can work on these production ready gateways, cameras, edge hardware. You can go buy it from Advantech, for instance, today, or even on Logic. And you're able to get the full ecosystem of tools that you would need to just, hey, I want to have an AI model, I want to have my application logic, and I want to have my device. And in that early R&D phase, you get the world. Fine. But then you start looking at it and you're like, I'm not using these libraries, I'm not using these optimizations. Maybe this is like offline only update mode. Great. Then you can opt out of as much of it as you need. And then you have a purpose built OS for your device, to your point, which is completely reproducible and can be managed on a scale from not from 1 to 100, from 100 to 100,000. Really excited about the customers that are going six figure device fleets on Jetson. Um, but that's a great segue. So, like, this tooling we build and the targets that we support are very strategic, right? So we're focused very heavy on like high end AI applications, but then we also want to provide support and consistent tooling for those that would move into a different application stack, or maybe moving from like leave the vendor names out of it, but um, from the highest cost, like NVIDIA humanoid brain, to something that would be like lower cost, higher volume that might be appropriate on a consumer product. What's that experience like?
Yeah, it's I think that our ability to target all of this offering of hardware and software is like a great middle ground. You mentioned a bunch of wonderful partners and places where you can purchase off the shelf hardware that can really start to solve a lot of problems for you. and then bringing to the table all of the ability that we pre-build all the world for, like Nvidia, for example, so that you can, even from the software side, just feel like you can make big strides in creating your product and programming your application that runs on that. It's really important because the alternatives to these, like we find are a lot of our the hardware manufacturing partners that we work with who build these gateways or devices that you can reach for. They kind of suffer from similar problems that the chip manufacturers do, which is that getting these devices to work and to boot up and be performant. In the case of AI, we need to worry about performance. We need things to be efficient, and we're basically taking the most complicated things that we've done in the world and making them work on tiny devices.
Yeah.
That can often require like a lot of custom modifications to even things like Linux. And Yocto in that case is a tool for those companies to be able to control um, those patches and maintain them and extend their offerings for use to customers without having to wait for them or attempt to get them merged into upstream Linux kernel, right? That could be a
Right.
really difficult task. And so, but all of the downsides being that there's a high level of complexity with Yocto directly, but we can extend that offering and make it through our extension system easy for the customers to be able to still leverage that the patches or whatever modifications might be necessary to make that piece of hardware function performantly in the environment that they need, without having to extend all of that complexity of Yocto forward to their customers. They want to sell hardware that they can offer as a commoditized means to help you get your product into the field. And we're offering the software that finishes out that story that can also just end to end help you really deliver that final story that without having to be holden to the kernel maintainers or upstream projects waiting for them to accept your patches before operating systems like Ubuntu or Canonical and such could even support your stuff, right?
So I talked with a major silicon vendor last week who is just so excited about robotics and humanoids and this next wave of applications that's coming. And this was incredibly important to them, and that they're developing cutting edge hardware, new computer vision sensor solutions, and they can't wait for this work. Like, not they can't wait, like, I'm so excited about my birthday, can't wait, but they like physically can't wait for this stuff to be upstreamed. And so, what we provide is the ability to offer those capabilities to our customers and their end users as pre built supported binaries, extensions purpose built for that target. So, we support the base BSP, we provide a nice unified OS on top, and then we can bring in those vendor specialties or configurations or whatever as managed supported extensions, and their customers can get up and running on day one, which is really exciting.
Yeah, exactly. I mean, we don't treat like while we build packages to be able to build the world, we build Linux, n different ways, however many targets that we support. We support a lot of the dev kits, but we also support a lot of off-the-shelf hardware from a lot of our partner, and for those partners, with those subtle differences between different pieces of hardware, if the Linux kernel is different, we build that separate into a separate repository just to maintain for that target. And those all continue to get merged along the way. So you can kind of think of our distro as a purpose-built distro for those individual
Yeah,
targets, and not one
exactly.
that's generic, that's trying to be shoehorned to work across all of them. The magic sauce for us is really one where, yeah, we can make you feel like it's a really easy to use, comfortable experience. And then to the partners that we work with for their hardware, it works out really well for them because, yeah, they don't have to be waiting for that kind of stuff to get accepted upstream. We can just support them from you know engineering samples, and they can feel confident to be able to ship right afterwards. So.
Is it safe to say that my camera doesn't need your printer driver? Is that a good
Yeah, yeah.
comparison?
Yeah, I can't imagine how much of all the things we talked about of like possible solution cases. I don't see many embedded devices needing very many printer drivers.
Yeah, yeah.
Uh,
Unless it's just doing that. Yeah.
we'll do a ResNet facial recognition demo at a next conference, which has a Polaroid camera printer that just prints out the faces it sees. That'll finally bridge that gap.
So let's talk a little bit more about future state. I know we're over time today, but this is an enjoyable conversation as always. Um, the world is converging on models
Mhm.
and enablement and acceleration. And we are talking with some of the most bleeding edge companies that I mean, just even in the last few months, I mean, my mind is blown with the customers and partners we're bringing on. What is this new paradigm of models versus software?
Well, we're kind of at the foot of this massive super cycle that we're all waiting to take off, which is physical AI. And in order for it to happen, we need to be able to all act from a position where we don't have to be the smartest people in the room about absolutely everything. You're once again standing on the shoulders of giants. I shouldn't have to know about all of the giants that I'm standing on top of, or have deep knowledge in all of them to be able to get it to work. The world of if this, then that logical programming is just unrealistic when it's applied to the kind of scale and the types of problems that are being, existing in this world. There's a countless numbers of different kinds of devices and sensors and things that we need to measure or whatever. It's that can get shaken out of this physical space. Tons of things that can go wrong and react. And the move towards using models for this is a move towards a shift in computing from the paradigm of rigid, logical. I got teams of programmers that are just going to write, some ladder logic all day long and make this rigid system that works in this single environment and that does this specific task to one that can expect the unexpected. It's an intent-driven future, and we wouldn't be able to approach that with this rigid programming style. We have to move into this intent-driven style, which is driven from models that can act on more of a probabilistic perspective. It can start to be able to reason about things. And then with agentic programming these days, it just means that we have models that know how to be able to kind of convolute in creating plans to be able to achieve your goal, that it knows what's at hand, like what sensors or what motors or what functions it might have access to be able to accomplish your goal. And that kind of lets us bake the knowledge into these data sets, these models, to empower the system to be able to act with this intent. So no longer do we need to be just creating all of this rigid code or hiring like teams of hundreds of programmers to be able to accomplish jobs. We can train the knowledge of the tasks that we need it to be able to accomplish into a way that it can reason about in its environment how it can best and most accurately accomplish this job. And it's how it applies back to us for a distro as well, is that these the world is going to be meta programmed.
Yeah.
We're no longer writing the programs. We're writing the models that on the fly write the programs. And similarly speaking, you should be able to, in ways, meta program the rest of the operating system or the dependencies that you need to ship alongside of your app. And with our tools and our structure, meta programming our systems to be able to give you the runtimes that you need with just what you need to satisfy the goal of the application you want to be able to ship is also reasonable and within reach too. So meta program the world, right?
Prompts as firmware. It's insane.
Yeah.
Well, I think this is a good place to pause. Very nice conversation. If anything we shared here today is of interest to you and you're looking to have a more reliable way to sell your edge products, Avocado is a fantastic answer there. And we will build the world so that you don't have to. Justin, thanks for coming on, and we'll see you guys next time.
Thanks, Bill. Always great.